Today we are going to discuss about some of the technique in cryptography and network security. Your subject code is 191CS722. We are going to discuss about the topic of classical substitution ciphers method. In substitution, we are replacing the plain text by other letter or by number or symbol. We are replacing the plain text bit by any of the other letter or number or symbol. If it is a single bit, we are doing like this. If it is a sequence of bit, means we are substituting. This substitutions involves replacing the plain text bit pattern with cipher text bit pattern. Caesar cipher is the earliest substitution cipher method. It was invented by Julius Caesar, so that it was named as Caesar cipher. It was first attested used in military affair. It replaces the each letter by third letter. For example, if the plain text is meet me after the toga party, means M was replaced by P, because if add 3 letter you will get the P. M, after M, N, O, you will get what is the third letter? You will get the third letter as P. So M is replaced, M was substituted by P. After 3 E, for the like that you have to replace each and every letter, you have to replace with plus 3, add plus 3, after what you are getting, replace that, you will get the ciphertext. CCS cipher can defined as though, what is the input? Input means defined as the ABCD, like what we are getting the output. A was replaced as third letter. What is the third letter? D. Like that we are getting for each and every letter. Okay, Z was replaced with C, like that. If how we can represent it mathematically, means 0 to Z, so 0 to 25 for each and every alphabetical letter. If it is represented in numerical, means 0 to 25. Then we have the CCS cipher as, that is C means ciphertext. Ciphertext is a function of, so encrypted. So we are representing for that only encryption function. For that function we have to pass 2 parameter. What is the 2 parameter we need? We need the plain text and key. If we pass the plain text with the key, means for the encryption function, means we get ciphertext. This was in CCS cipher P plus K mod 26. How we derive the plain text? Decryption function. In decryption functions we are passing key and what we have? Ciphertext. If we have ciphertext with the key, means we will get the plain text. C minus K mod 26, we will get the ciphertext. Mono alphabetic ciphers. Rather than just shifting the alphabet, we could shuffle or permute the letter orbitally. Each plain text letter maps a different random ciphertext, so we are able to get not only the 26, not only the 3 as only one key space, we are increasing the key space in the mono alphabetic ciphers. Yeah, if our plain text is given as A to Z, ciphertext given, it was replaced by the, if it is plain text is, if we wish to replace the letters, what we have to do? What is the ciphertext for I? For you have to find out and replace with that. Okay. For A, D, B, K, C, V, D, Q, like that, what we are getting? For I, W. Okay. For F, F is very easy only, no? A, B, C, D, E, F. 1, 2, 3, 4, 5, sixth letter. So what is the sixth letter? 1, 2, 3, 4, 5, sixth letter is I. So like that we are writing that. why we are going for the monoalphabetic letter? We are thinking like that it may be more secure like that, but not like that. Key size may be now 25 character. Now we have a total keys of 26 factorial, that is 4 into 10 power 26 character we can get. But with some keys we may think of this may be a secure one, but it is a wrong. The problem why it is wrong means problem is language characteristics. We are using some of the language has redundancy, so cryptanalysis is easy. So that is breakable. Cryptanalysis means we could find out the ciphertext very easily. Human languages are redundant. That is example, some of the letters we are using frequently and some letters are not used. Examples, letters are not equally commonly used. In English, E is by far the most letter, followed by T, R, N, I, O, A is S. Z, J, K, Q, X are not, we are using fairly. We could see in this picture the frequency of the letters. Some frequency, that is E is most frequently used, but least frequency used is Z. Like that we are using some of the letter in some of the letter frequently, some of the letter very less frequently. So we are moving to the Playfair cipher. Not even the large number of keys in monoalphabetic cipher provide the security. For that only we are moving the Playfair cipher. One approach for improving the security was encrypt with multiple letters. So Playfair cipher is an example for that. It is what invented by Charles Wheatstone in 1854, named after his friend Baron Playfair. In Playfair we have a key matrix of 5 cross 5 matrix of letters based on the keyword. Fill the letter of keyword in the 5 cross 5 matrix. Fill the rest of the matrix with other letter. Example, if our keyword is monarchy, means MONARCHY we written, and how many rows and columns pending, we will have to fill that matrix letters. What are the letters in keyword, we have to just left and we will we will fill the letter by rest of the letters. Okay. What is the first letter? A. A is in the keyword itself, so leave that. B is not in the keyword, so put B, and C is there, leave D. Like that you have to fill the rest of the matrix. And how we are going to encrypt and decrypt means, if first step is plain text is encrypted by only at a time we will encrypt 2 character. So first step is split the word into 2 character. If a pair is repeated letter means, if maybe hello me, for example, if the letter hello means L repeated, so you don't use the repeated letter LL, replace with some other filler like character X. If both letters fall in the same row, replace each with the letter to the right. If both letters fall in the same column, you have to see in the matrix whether that character is fall in the same row or same column. If it is falling in the same column, means replace each with the letter below it. Otherwise, each letter is replaced by the letter in the same row and same column. We will discuss in the next slide. See this slide. Our message is move forward. Our plain text is we are splitting into 2 MOVEFORWAR. D is singly present that, so we will add extra letter, that is X is a filler letter. We are using the filler letter, okay, X. And then here so MOVEFORWAR for MO, M is in the first row, MO is in the same row. Same row means next character. So M was replaced with O and O is replaced with, what is the next character for O? N. So we are replacing. V for VE, V, find out the V. Where is V present? V is in the second column, last row, and VE first row, third row in first column. It is not fall in the same row, it was not fall in the same same column. So what we have to do, you have to see the rules first. See the rules first. If both letter fall in the same row, replace. No, not like that. So first rule is not applicable. Second rule is, what is the third rule? If the both letter in the same column, no, not in the, otherwise each letter is replaced by the letter in the same row and in the column of the other letter of the pair, okay. What will get for U, V is replaced with U, because in the same row what we are getting U, and for same column V, E is here, the same column we are having the letter F, and FO is replaced with PH. Why? Because F and O is in the same column, so we are replacing with PH, okay. A letter which are in the down, we are substituting. Like that we are getting the ciphertext now. As for the plain text, move forward. What is the ciphertext we are getting? On UF PH NEZ RM BZ, okay. Is it clear? Now we are moving to the transposition cipher. Transposition cipher, or we may tell like that permutation cipher also. They hide the message by rearranging the letter or letter order without altering the actual letter. In substitutions, what we are doing, we are substituting the character by other character. In transposition, we are not changing, we are changing only the position only, okay. That is transpositions. We can recognize these since have the same frequency distributions as the original text, okay. Rail fence method is one of the example for that.